Hi there, this is Mrs. Often, and I am here to talk a little bit about how to write indirect proofs. These are also known as proofs by contradiction, and you will see them frequently throughout geometry and algebra. So, what we do in an indirect proof is we assume that what we are to prove is not true, and then we go about showing how that must be false. So I'm going to talk about how to write that first sentence and then kind of some general steps to follow, a kind of skeleton of a proof where you would then be able to fill in and work things out so that you can perform an indirect proof on your own. So, as always, we want to start with the givens and we want to start out with that information to write our first sentence of the indirect proof. So if we have to write a proof, we're going to identify what we need to prove. And our first statement, instead of being the given, is going to be temporarily assume whatever you have to prove is not true. If you are given a conditional statement, and you're going to be proving that the conclusion is true, well, in your indirect proof, you're going to say, let's temporarily assume that this conclusion is false. So if we're given, if an angle's measure is 100 degrees, then the angle is obtuse, then we will say temporarily assume the angle is not obtuse, and then we'll say it is given that the angle has a measure of 100 degrees. By the definition of obtuse angle, any angle with a measure greater than 90 degrees is obtuse. 100 is greater than 90. This directly contradicts our original assumption, and therefore the angle must be obtuse. Okay. If we are instead given kind of a proof format, given triangle ABC, if the measure of angle A is 90 degrees, then the triangle is a right triangle. We are going to say temporarily assume the triangle is not a right triangle. Sometimes in indirect proofs or proofs by contradiction, you will just see statements like, let us assume that. And this is similar to saying temporarily assume. So here is kind of the skeleton of the proof, and you'll see this in our section on indirect proof and our assignment for it within the Google Classroom. This PDF is available for you to have either in PDF form or in Google Doc form. So you can just copy and paste and fill stuff in for yourself to be able to more easily follow that format for the indirect proof. So we're going to say temporarily assume that, and then it follows that. This contradicts either our given information or a theorem or postulate, other things that you may be given, definitions, and therefore the temporary assumption that blah, 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 what we were to prove has to be false, and instead what we are trying to prove must be true. So here's an example of an indirect proof, and I'm just going to zoom in a little bit so it's easier to see. So we have scalene triangle ABC with segment AE bisecting angle A, and we're going to prove that AE is not perpendicular to BC. So just kind of coming up with a plan for this, I know that if a triangle is scalene, AB is not congruent to AC, nor is BC congruent to either AB or AC. So I'm going to write my first sentence saying, temporarily assume that AE is perpendicular to BC. And then we'll take it from there. What does that mean? And how does that potentially contradict the other things that we have been given? All right, so we're going to temporarily assume that AE is perpendicular to BC. That means that angle 3 and angle 4, AEB and AEC, are right angles by the definition of perpendicular. Then all right angles are congruent, so 3 and 4 must be congruent. Also, it is given that AE bisects A. Therefore, angles 1 and 2 are congruent by the definition of angle bisector. AE is congruent to AE by the reflexive property. These are all things that we know must be true. Now, that means that BAE and CAE are congruent triangles, which would mean that BA has to be congruent to AC by CPCTC. This contradicts our given information that ABC is scalene. Therefore, our temporary assumption that AE is not perpendicular to BC must be false, and thus it follows that AE is not perpendicular to BC. So that is an example of an indirect proof. I hope this has been helpful to you, and we'll have more practice with writing indirect proofs in class.